Hi, and welcome to the video for section 2.3. This is the one and only video for this section. So in this section, we're going to be looking at getting information from the graph of a function. So the first thing we're going to look at is domain, which is what? When we talk about domain of a function, we talk about all the possible x values. We also have a term that's known as the range. And the range is what are all the possible y values. So domain we looked at, like when we have square root, if we have a polynomial in the denominator, if we have something like that, it restricts our domain. Well, our range is also restricted based upon what values we have for the x. So if we go back to like the paycheck example, my domain would be anything, it would be positive numbers, 0 up to infinity, but my range would be what? Well, my range would also be 0 to infinity. I couldn't make negative $3, unless you want to call it taxes, but it's basically what x values is our domain, what y values are our range. So for example, if I'm given that f of x is equal to the square root of 4 minus x squared. So if I was to graph this, or if you were given this graph, this is basically a half circle that looks like that. And if I was asked, what's the domain and what's the range? Well, the domain is what? It's all the x values that could be plugged into this function. And we can just look at the graph, and this is why sometimes graphing makes this a lot easier than trying to figure out just by looking at the function, well, I don't know what values they are, but if I have the graph, or if I graph it, then it makes it easy, because domain is what? It's my x values, so it goes from negative 2 all the way up to positive 2. And are these guys included? Well, they're actually hitting these values of negative 2 and positive 2, so yes, they're included, which means it gets the brackets. Well, how about the range? With this function, given that that's my function, the range goes what? The range goes from 0 up to positive 2. So 0 to 2, again 0 is included because the graph comes all the way down to the x-axis, and 2 is the actual value when x is 0. So both of these are included, so I would get the brackets around 0 to 2. So that's how, if I'm given a graph, I can figure out what's my domain and what's my range, as opposed to having to try to do any calculations. Sometimes it's easier just to look at the graph and be able to figure it out. The next idea that we have is increasing and decreasing functions. So by definition, f is increasing. So I'm going to give you the formal definition. As we'll see, increasing function just means it's going uphill as we move from left to right, going downhill as we move from left to right. So what? This guy would be increasing up to here, but decreasing after we get past 0. So is it going uphill or is it going downhill? And to put that into math terminology or math verbiage here, f is increasing on the interval I if f of x1 is less than f of x2 when x1 is less than x2 on the interval I. So as you can see, you try to read this, you're like, is this a foreign language? I have no idea what's going on here. But it just means what? If x1 is less than x2, so let's say that's x1, let's say that's x2, so f of x1 is what? It's this guy. F of x2 would be that one. So that means this is f of x2, this is f of x1. So f of x1 is less than f of x2 if x1 is less than x2. So similarly, f is decreasing on the interval I if f of x1 is greater than f of x2 when x1 is less than x2 on the interval I. So if I look at just this right half now, let's say this is my x1, let's say that's my x2. So f of x1 is here, f of x2 is there, whoops, x2. So what? F of x1 is bigger than f of x2, even though x1 is less than x2. But again, the idea behind it, if you don't get confused with all the wording, is it going uphill? Increasing. Is it going downhill? Decreasing. Now, depending what our graph looks like, we could have a bunch of different intervals where it's increasing or decreasing, and when it changes, so let's say I have this graph, we'll call that point A, that point B, that's point C, and the end, point D. So it's what? From A to B, we're increasing. From B to C, we're decreasing. And from C to D, we're back to increasing. So it doesn't have to just be one or the other or one of each and that's it. Depending how far this thing goes, it could be keep changing from increasing to decreasing. We also have what's known as, so if I look at, let's say just this piece here, the graph. Well, I have what? I have a high point in there. And so this is what's known as a local maximum. It's not the absolute max, or it's not the max of the function. Why? Because out here at D, D is obviously higher than B. But local, within this little area, that's a local maximum. That's as high as it gets within this area that I block off here. And similarly, C, if I just look at a small area here, C is the bottom of this curve, and this is a local minimum. So again, it's not the minimum for the whole function, because that would what? That would be A down here at the starting point. But if I just am looking at small intervals, that would be the local minimum. And we have that feature that whenever we switch from an increasing to decreasing or a decreasing to increasing, we're going to have a local max or a local min. Because if we're switching from one to the other, it means that we have to either be at the top of the hill or the bottom of the hill. Thus, that gives us a local max or a local min. So the last part of this video, let's say we're given f of x is equal to 12x squared plus 4x to the third power minus 3x to the fourth power. And given that function, I want to find the domain and range. And I also want to know the intervals where it's increasing or decreasing. So if I was to graph this function, there's different graphing software out there. I can tell you guys about some of that if you need to know. You could plug in values on a table and plot the points. But if I was to graph this, so the top of this little hill here is -1, +5, and over here, this value is 232. And then it goes off to -infinity on both sides. So the domain is what? Well, what are all the x values? Well, that I can kind of figure out if I wanted to just from the function that was given. I don't have any square roots. I don't have any denominators. So that means what? The domain is all real numbers, which if I put it in interval notation is -infinity to +infinity. How about the range? Well, that's why graphing this can help. So range is what? How far down do I get to how far up do I get? Well, how far down? I'm down at -infinity. But how high do I get? Well, the highest point is right here at 232. So the y value, the biggest y value I have is 32. And because it actually gets up to that point, it's going to get a bracket. So the domain, -infinity to +infinity. The range, -infinity up to 32. So I'm looking vertically on this thing. And I wouldn't write this, don't write it as, don't go the other way. Don't say like, oh, it's 32 down to a -infinity. That's not correct notation. So the left number is always smaller than the right. So obviously 32 is not less than -infinity. So make sure that you order it correctly. Second is where is it increasing and where is it decreasing? Well, it's increasing what? It's coming uphill here from the left until we get to -1, 5. And so we're asking what x values am I going uphill? Well, it's everything from -infinity until I hit -1. Then I start decreasing till I hit the origin. So at this point here, this is 0, 0, where it switches back up. So it goes back uphill from where? From 0 to 2. 0 is included. 2 is included. So those are both my increasing. How about decreasing? Well, it's from where I hit -1. So -1 down to 0. And then from 2 back to -infinity, well, back to +infinity, because what? I'm looking at all the x values. What are my x values where this thing is going downhill? And it's from 2 out to +infinity. The actual value is -infinity, but it's going out to +infinity is how far I have to account for it. So I get 2 up to +infinity. So that's it. Like I said, only one video for this section, a little bit longer than most of the videos, but there's only one of them. The idea is being our domain and range. How can we look at a graph and figure that out? And then also, where are we increasing and decreasing on our intervals? Again, where are we going uphill, where are we going downhill? So come on back and we'll look at our next set of videos.